This is a spill evaporation model using exploCFD for a lab with a design that has suction vents in the ceiling, designed to pull out any fumes that might be flammable or toxic. We've modeled a methanol spill in the lab. That's where this blue line just above the floor is. That's the surface of the spilled methanol. With exploCFD version 9, you can now input the Antoine coefficients of any material and model its evaporation. Simply input the Antoine coefficients along with a couple of other parameters like diffusivity, and you're able to model this evaporation. Here's how the results look. Evaporation from the surface of the liquid, the interface between methanol liquid and the air. The vapors are being pulled upwards by the vents, and this is initially mostly just into the vent just above the spill, but over time the adjacent vents also pull vapors through. A more informative view of the consequences seen by just looking at the flammable range between the lower flammability limit and the upper flammability limit. Anything that's not in black in view here is in the flammable range. So if it's below or above, then it's just colored black and you don't see it. And you could see that initially the cloud is small, but it's growing over time. The cloud builds up near the ceiling of the laboratory. So you can see a fairly large flammable cloud extending from just above the spill, just above the surface of the liquid, to the ceiling, spanning the distance of these 3 suction vents. All of this is flammable, so if you have any ignition points near the ceiling for light switches, electrical outlets, or even the fans themselves, this cloud could ignite and produce significant overpressure. So the next time you want to model an evaporation of a spilled liquid, whatever it is, remember that exploCFD has the capability to do this automatically for any liquid. Does your software do that? Maybe it's time you gave exploCFD a try.